In this video, we will talk about numbers. We'll talk about what are natural numbers, what are whole numbers, integers, rational numbers, irrational numbers, real numbers, and finally complex numbers. So let's start with natural numbers. So all numbers that can be counted are called natural numbers. So let's say we have numbers such as 1, 1, 2, 3, 4, 5, and so on. These are numbers that you can count. So you can have one finger, two finger, three fingers, um, apple, one apple, three apple, five apples. Objects in the world are counted using these numbers. So these numbers are called natural numbers. They are naturally existing in the world. Now, if you have a set of natural numbers, what you can do is you can define some operations on them. So let's say you have natural numbers. The natural numbers are the set of numbers starting from 1 to all the way to the largest number possible. Now, you can define very easily two different operations of natural numbers. One of them is addition. If you take any two natural numbers, so let's say we take the natural number 2 and we take the other natural number 5, and then we add them together, we get another natural number, which is 7. So if you take any natural number, you add it to another natural number, you'll get another natural number. We can also define a function of multiplication. So you can take a natural number, let's say 2, and multiply it with another natural number 4. You will get a number which will be 8, which will also be a natural number. So if you take two natural numbers, or if you add them, or if you multiply them, you'll get another natural number. So in that sense, these operations are closed on natural numbers. But if you do, let's say we do an operation such as you take a natural number, let's say 3, and let's say we add it to a number, some number that gives me 3 again, right? And so if you, let's say you take 3 apples, you add some other number of apples to 3 apples, but in the end, you only got 3 apples. So how many apples were added? What was this number that was added to 3 to get the 3 number again? So the number which is added here is, of course, 0. We know. If we add 0 to 3, we get 3 back. But this number 0 is not in the set of natural numbers. This is a new number that we need to have. So 0 now, if we add 0 to the set of natural numbers, we make a new set. This set of numbers is called whole numbers. Whole numbers. So whole numbers are a set of numbers that starts from 0 and then goes 1, 2, 3, and so on, up to the largest number. So the set of natural numbers along with 0 is called the whole number. And now that we have this number 0, we can perform this identity operation. Identity operation, which is you take any natural number, you add 0 to it, you get another natural number. So this operation is only allowed when you have 0 in the set. So that once you include 0 in the set of a natural numbers, you get a new set, which is the whole number. Now, if you have the operation of addition, we can also think of a similar operation called subtraction. Subtraction. So let's say we take any two natural numbers or whole numbers. Um, Let's say we take the natural number 7 and subtract 2, or we take a whole number or natural number 7 and subtract another whole number from it, 2, we get a number which is 5. So all three of these are in the set of whole numbers. 7, 2, and 5 are in the set of whole numbers. But we could have taken another example. Let's say we actually subtract, let's say we subtract 3. So we take the natural number or whole number 3 and subtract 8 from this 3. Now in this case, we will see that the number which is being subtracted, 8, is larger than the number 3. So, of course, the result here is minus 5, but minus 5 is not an, um, an element of the set of natural numbers or whole numbers. We whole numbers start from 0 and go all the way up to infinity, but it doesn't have any concept of negative numbers. So once you add the operation of subtraction, which allows you to subtract any two whole numbers, then you need a new set of numbers, which are essentially the negative of the natural numbers. So once you include all these negative numbers, we get a new set of numbers that are called integers. Okay, so integers are a set. So we already had the natural numbers 1, 2, 3, 4, and so on. We included the number 0 to make the set of a set of whole numbers. Now we need the negative numbers. So minus 1, minus 2, minus 3, minus 4, and so on. So this set of numbers that has all positive numbers, 1, 2, 3, 4, and so on, includes the value 0 and has all the negative numbers, minus 1, minus 2, minus 3, minus 4. This set of numbers is called integers. Now, once you have the operation of integer, you can define uh, in addition to, so we have these operations: addition, multiplication, identity, and subtraction. Now that you have these integers, we take a number and we define a new operation. So in this new operation, let's say we have two numbers, x and y, on which once we perform this operation, we get a 0. Okay, so we call this operation inverse operation. Okay? So what we want is we take a number, we take two numbers, we perform an operation such that we got a 0. What should be this number y? So if this operation was, let's say, addition, let's say we were doing addition. Now we are looking for the inverse of the operation addition, which in this case is subtraction. So what should be this number y? Well, this number y should be equal to the negative of x. When you take the number x, any number x, it has a conjugate value on the other side, which is minus 3. Once you add these two numbers, 3 and minus 3, you get a 0. So for every number, there exists an inverse value, which once you add to that number, it's 0. This operation is called the inverse of addition. Okay, so now we have integers. Once you have integers, we have integers include all the values, all the positive numbers, 0, and all negative numbers. Now, let's define, so remember that we had another operation called multiplication. So once you multiply two numbers, let's say you multiply 4 multiplied by 3 gave you 12, okay? So you multiply any two numbers, we get another number. But what would be the inverse of the multiplication operator? We know this is division. So the way we multiplied, we added two numbers and we got another number. When we added two numbers, we got another number. We defined another operation called subtraction, which was inverse of addition that gave us, which helped us take the difference between any two numbers. Similarly, when you have two numbers, you can multiply them to get another number. And the inverse of that operation is division. So we can also divide any two numbers. So let's say we divide the number 12 by 3. If we divide the number 12 by 3, we get as a result 4, which in this case is also an integer. So you take any integer, 12, you divide it by another integer, you get a third integer, which is 4. We could have done this with a negative number too, so we could have taken, let's say, minus 8 divided this by, let's say, minus 2. Both of these are integers, both of these are negative integers. When you divide them, you get an integer which is 4, which is a positive number, but these are all integers. Now, you see what I'm doing here is I'm dividing two numbers, a number which is in its magnitude, in this case, larger, the number which is being divided is larger than the number which is divided. But we could have done some other way. So let's say, what happens when we divide 3 by 12? Okay. Now this number 3 by 12 is a number which is less than 1, right? Now since this number is less than 1, but it's not equal to 0. And on our set of integers, we only have values 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus, and so on. So this number 3 by 12, whenever you divide two integers where the integers which is being divided is in magnitude larger than the integer which is in the uh, divisor, you don't get another integer. This is not equal to another integer. Okay. So now we need a new set of numbers that can have these kind of fractions or ratios. These numbers are called rational numbers. Rational numbers. Okay. So rational numbers are numbers that can be that can be written as a fraction in the form P over Q. Okay. So all numbers that can be written in the form P over Q, where P is an integer and Q is an integer. So where P and Q are both integers. Okay, these numbers are called rational numbers. So if you look at now the number that we had, so we had 0, 1, 2, 3, and so on. Similarly, we had minus 1, minus 2, minus 3, and so on. Now that we have these rational numbers, we can also define numbers in between these quantities. So let's say we can take half. So half would be a number 1 over 2, which would be somewhere here. We can similarly define 3 over 2, 5 over 2, and so on. Similarly, we can have a minus 1 half, minus 3 over 2, minus 5 over 2, and so on. So all these numbers now are the set of rational numbers. By the way, you should also realize that the number that we had earlier, all the integers can also be, integers can be written as rational numbers. Rational numbers. This is because you take any integer, for example, 6, you can always write 6 as 6 divided by 1. So this is a form P over Q, right? So any integer can be written in the form P over Q. So all integers are a part of rational numbers. They are a subset of the set of rational numbers. So these numbers, which can be written in the form P by Q, are called rational numbers. Now, once we have rational numbers, we interestingly have um, the operation of division. We can divide now any number, and we will always be able to find the solution of the division. Now, before we talk about irrational numbers, so let's talk about something else. Let's say we have two numbers. Let's say we have any one number, for example. Let's say we have an integer 3. We can always multiply the integer with itself, right? We can multiply two integers which are the same integer. This operation is called squaring, by the way. So if you take an integer and multiply it with itself, this operation is called square. You square the number, okay? So here, this is represented by 3 to the power 2. So 3 to the power 2 means that 3 multiplied by 3. The answer here, of course, is 9. Okay, you can take any two numbers, any two rational numbers, and you can always square them, and you will get another rational number. Now, as we have the operation of square, the way we had the operation of addition and multiplication, and we got their inverse operation, which were subtraction and division. For square, there is another operation which is called square root. Square root. Let's talk about the operation of square root. So let's first look at the square of several numbers. So 1 square would be equal to 1. 2 square would be equal to 4. 3 squared would be equal to 9, and so on. So if you square these numbers 1, 2, 3, and so on, you will get the numbers 1, 4, 9, and so on. So if you want to define the operation of square root, so let's say we take the square root of the number 1. Square root is denoted by the symbol like this. So the square root of 1 would be 1. So when you do the square of 1, you get the number 1. When you do the square root of this number 1, you get this number 1. It will be clearer if you look at the square root of, let's say, 4. So square of the number 2 is 4. So square root of number 4 would be equal to 2. You can, square root of 9 would be equal to 3, and so on. The way the square operation is, you take a number and put the square operator on the top of the number. We can also represent the square root as 4 to the power half. So squaring is multiplying the number with itself. Square root is like doing this operation where you're doing the square root of 4, which is represented at 4 to the power half. So this symbol where we have one, so this symbol where you have 4 in this kind of a hat is similar to this symbol 4 to the power half, which is equal to 2, or 9 to the power half is equal to 9, 1 to the power half is equal to 1. Okay, so the way we have the operation of squaring, we also have the operation of square root. But the interesting thing you will see that the square operation we could define for all the integers or all rational numbers, 1, 2, 3. The square root operation only exists for certain numbers, at least in the example I have given you here. So you can take the square root of 1, which will give you 1. You can take the square root of 4, which will give you 2, square root of 9, which will give you 3. But what happens to the number in between? So what happens to the square root of, let's say, 2 or square root of 3? You know, and then there are, again, there are numbers in between. So between 1 and 4, we had 2 and 3, and we could have taken the square root of 2 or square root of 3. Similarly, square root of 5, 6, 7, and so on. Now, these numbers, square root of 2 and square root of 3, these are numbers such that if you actually calculate the square root of 2, these are numbers, this number is 1.414 and so on. Similarly, square root of 3 is 1.732 and so on. So there are certain numbers which, if you represent in terms of decimal numbers, they will always have some other value. So if you, for example, if you take the number 2 by 3, okay, 2 by 3 is 0.666666. Always you will get the number 6 forever. If you take the number 1 over 2, this is equal to 0.50000, and so on. Now, these are, of course, rational numbers. Rational numbers. So rational numbers can be put in the form P over Q, and if you put them in the decimal notation, they will either have the same number or same set of numbers that will repeat after themselves, or they will always have trailing zeros. But there are certain numbers that if you represent them in the form of the decimal form, so square root of 2 is 1.4142135627, so on. You can take a group of 3 of them or 4 of them or 5 of them. You can keep looking at all the decimal expansion. You will never see a pattern that repeats itself, and you will never get zeros, trailing zeros. Such numbers which never have an ending are called irrational numbers. Irrational numbers. Okay, these numbers are numbers that if you put it in the decimal form, there is never a group of digits that will repeat, or you will never get a set of zeros, trailing zeros. These numbers can never be put in the form, never be put in the form P over Q. Okay, these numbers can never be put in the form P over Q, and that's why they are called irrational numbers. So now if you look at our numbers, we had 0, we had 1, we had 2, we had 3, and so on. Similarly, we had -1, -2, -3. These were our integers. We defined rational numbers that defined as the numbers which were of the form P over Q, such as 1/2, -half, 3 over 2, -3 over 2, and so on. And there are other numbers, like you can also have 3 over 4 and 5 over 6, and so on. So there were numbers in between. These were the rational numbers. Okay. So between every two numbers here, there were lots of numbers. They were the rational numbers. But again, there were certain numbers like square root of 2, which is 1.414. There was a number here which was larger than 1, less than 3.5, but it couldn't be put in the form P over Q. So all such numbers now exist, which are called the irrational numbers. And if you include the set of all rational numbers all rational numbers and all irrational numbers. Irrational numbers. If you take all rational numbers and all irrational numbers, then no number in between any two numbers will be undefined. You can have all the numbers from essentially from minus infinity to plus infinity. Okay, you have a zero, then you have a one, two, three, minus one, minus two, minus three. You have numbers that are fractions, which are rational numbers, and you also have numbers that are not as a fraction, they're irrational numbers. But if you include all of them, then there will be no point on this line which cannot be represented by either a rational or an irrational number. So if you take all these values together, you put them together, this set of numbers is called real numbers. So real numbers represent a set of all numbers that can be represented on the number line. Essentially, it has all possible numbers um, from minus infinity to plus infinity, and these numbers are called real numbers. Okay, that's very good. Now, you remember we defined the operation of square root. And when I was doing the square root operation, you can see that when we square a number, you can take, I took here only positive value, but we could have also taken negative value. So for example, we can do the square of 2, which will give me 4. But I can also do the square of minus 2. So you can multiply a negative number with itself, which gives me plus 4. Uh, so this is interesting because here there are two different numbers, 2 plus 2, which is a positive number, and here we have minus 2, which is a negative number. But if you square them, you only get positive value, right? So this is interesting because if you take any negative number, you square it, you get a positive number. But we also define the operation of square root. So the way we looked at it earlier, all the numbers which were on this side, if you take the square root of those numbers, so let me do this, minus 3 square is 9, and 3 square is also 9. So earlier what we did was we took the square root of the numbers on this side. So let's say the square root of, second, the square root of 4 was equal to 2. The square root of 9 is equal to 3. Okay, so all the numbers for which we were taking square roots were actually positive numbers. But what if these numbers are negative, right? So if we, let's say, what would happen if we did the negative square root of the square root of minus 4? Because every time we do the square of a number, we always get a positive value. So it's almost, so there's no way we can take the square root of a number, of a negative number, and get a number on this side. What happens here? So in this case, we can see, because square operation of all real numbers will give you a positive value, we cannot actually define the operation of square root on the set of real numbers. We cannot do that. So we need another operation and another set of numbers. So first of all, we can always, let's look at this number, minus of 4. Minus of 4, we can always write as product minus 1 times 4. We can write minus 4 as a product of the number minus 1 times 4, and we can take the square root of this product. This can be written as square root of minus 1 here multiplied by square root of 4. Okay. Now, we know the square root of 4. Square root of 4 is equal to 2. So what we get is square root of minus 1 times 2. And this could be done for any real number, by the way. If in place of minus 4, I had some other real number minus of x, I could always write it as minus 1 times x and then I would get minus 1 times the square root of x. Okay, so for any real number, I can always get the magnitude of that number, which is a positive number. I can take the square root of that number very easily. The only issue I have is how do I find the square root of this number minus 1? So what we do now is we define a new number. This number is represented by the symbol I. Physicists define it with the symbol I. Mathematicians give it the symbol J. Okay, doesn't matter. You can pick any convention you want. So what we do is we are now going to define a new number. The way we had defined 0 as a new number to have whole numbers, from natural number to go to whole numbers, we define a new number which was 0. We go from whole numbers to integers, we define a new set of numbers which were negative numbers. So for every positive number, there was a negative number. Similarly, we can define a new number which is either I or J, such that if you square this new number, you get minus 1. Okay? If we define this new number in this way, then we can always say, so the square of that number is equal to minus 1. So, which gives us that the square root of minus 1 should be equal to this number I. Okay? So, we have to define now a new number I, and this new number is such that the square of this number is equal to minus 1. Now, how does that help us? So once we have this new number I, now we can start taking the square root of any negative number. So let's say minus 16. Minus 16 can be written as minus 1 times 16, which is minus 1, square root of minus 1 times square root of 16, which would be equal to 4. So square root of 16 is 4. And this number, square root of minus 1, is, I can represent it as I. So all such numbers which are the square root of a negative number, um, these can be represented in this form. Some positive some positive number multiplied by I. Okay, and such numbers are called imaginary numbers. Imaginary numbers. Okay, so we had the real numbers. Real numbers were all rational and irrational numbers. Um, these numbers are called imaginary numbers. And you can see very clearly that imaginary numbers simply have the real number, which in this case is the value 4, multiplied by this new number that we defined, which was I. Okay, so imaginary numbers are essentially a product of a real number with I. Now that we have imaginary numbers, we can define a new set of numbers that are called complex numbers. Complex numbers. So complex numbers are numbers that can be written in the form a plus I b. Okay. So complex numbers are numbers which can be written in the form a plus ib, where a and b are both real numbers, and I square equals minus 1. Okay, that's the way we define this number I. So a and b in this case are both real numbers, and I squared is equal to minus 1. Now, this complex number a plus ib, as you can see, it has two parts. One part is a purely real part. So a is the purely real part. Purely real number. Okay, and I times b is the imaginary part. I times I is the imaginary part. Okay. So every complex number has two parts, the real part and the imaginary part. The real part is the first part, it doesn't have any I, and the imaginary part is the number that comes I, where imaginary part has I multiplied by a real number. Okay. By the way, all real numbers are also complex numbers. Okay, so complex number is the larger set. Real numbers is comes inside the set of complex numbers, because if you take any real number, let's say, for example, 5, okay, this number can always be written as 5 plus 0 times I. Okay, because 0 multiplied by any number is 0. So when you multiply 0 by I is equal to 0. So this 5 can always be written as 5 plus 0I. But this form of a number is a complex number. 0 is of course a real number. 5 is a real number. I is imaginary. So this form 5 plus 0 times I is the same form as A plus IB, where A equals to 5 and B equal to 0. So all real numbers are also a part of the larger set, which is called complex numbers. And now once you have real numbers and complex numbers, so we can also represent them. So remember, real numbers were represented on the number line like this. You have 0, you have plus infinity, minus infinity. To represent complex number, what we do is um, we, rather than having a number line, what we have now is a number plane. Okay, so in this number plane, all the real part is represented along the x-axis, you can say, and the imaginary part, you can think of it as y-axis as the imaginary part. So, so a number could have a real part and an imaginary part. Let's say a number a plus ib will have a real part, which is a. It will be somewhere here. This part is the imaginary. So you can think of as plus and minus infinity. The way you have plus infinity and minus infinity, you could have plus imaginary infinity and minus of imaginary infinity. Then in this case, IB would be represented somewhere here. Okay. And the number A plus IB would be represented on this plane as a number here, which is A plus IB. Okay, so real numbers are represented on a line, complex numbers are represented on a plane, where purely real numbers are represented along the x-axis and purely imaginary numbers are represented along the y-axis. But the combination of a real and complex number, a real and imaginary number, which is a complex number, will be represented as a point on this plane. Okay, so this is an overview of different types of numbers. Thank you.